back, everyone, to the Swarm News Podcast. This episode is True Challenges in the World of UAS. I'm Joshua Hill, co founder of the Swarm News Podcast, and as always, I'm here with my co host.
And hello, everyone. I'm Vincent Lewis, and we'd like to say thank you first to all those who have been following and subscribed and liked our content. We thank you for all those who have been following us, and we would like to ask that if you haven't started to follow us, that you will follow us. Hopefully, like our content and try to come back for whenever we have our new stuff coming up. Back to you, Josh.
Yeah, so today we're diving into one of the most ambiguous engineering challenges I've seen the US government put out recently. Designing a drone weighing around 50 pounds that can safely lift between 110 and 150 pounds. That's basically requiring a drone that can lift almost 3 times its own mass. That's like an average person who weighs 200 pounds asking them to deadlift 600 pounds. And here's the kicker. The challenge was originally due by January 2026, but has now been extended until 1 May 2026, and registration will open on 5 January of 2026.
And this isn't just a tech challenge, it's a strategy. It's about logistics. It's about contested environments, and it's about autonomy for the future. This kind of unmanned capability could change everything from resupply to emergency response to covert ISR to battlefield utility to homeland security and disaster risk management. This is going to be a game changer in a lot of ways.
Yeah, so let me frame this out for the veterans listening who've worked in operations. In my military career, we constantly struggled with last minute logistics, moving critical items for special ops or ISR detachments without leaving a footprint, resupplying ammo, batteries, communications gear without exposing convoys. Imagine having a 50-pound drone that can drop medical kits, SIGINT front end antennas, spare batteries for dismount recon, lightweight munitions, encryption modules, mini sensors like unintended ground surveillance nodes. None of this is sci-fi anymore. It's force multiplication.
Yeah, I agree. And the challenge's timeline is going to be aggressive. It's May 2026 when everything is going to be, or when the teams that have been accepted will be going in and challenging against each other. And that's pretty much right around the corner. DLD isn't making this challenging because it's a cool idea or a thought. They're responding to a real world operational need and a problem that we see across the board. Need to be more reliable for the sUAS as we know it to be basically a reliable system as a heavy lift capable aircraft. They haven't been there before. And this helps to bring convoys that are being normally vulnerable for a log pack for Army and military guys to know that basically have to worry about getting hit from all aspects of either IEDs, air assets, and also ground-based assets. Helicopters are typically your way of kind of getting things back and forth, but they're expensive, high maintenance, a lot of costs, logistics to go into even getting those to places. Whereas something like this can literally eliminate that in a massive way. Tactical resupplies from larger airframes isn't as easy also because C-130 landing in locations isn't always the easiest. And they also have to go into contested airspace or C5 getting things in. A lot of requirements for big airfields for those. So having something that can carry at least a minimal size package to a decent area to help out a lot.
Yeah, exactly. And anyone who's operated in CENTCOM, PACOM, or UCOM knows this. You don't always get an air corridor. Sometimes you can't risk a Black Hawk. Sometimes the terrain is just too exposed. Sometimes the enemy EW picture is too unknown. When I was working SIGINT and ELINT target development, one of the problems we consistently addressed was how to recover, reposition, or in-place sensor nodes in denied space without risking lives. A drone like this could drive a long-range emitter, drop a slaved receiver, position an ELINT antenna, and do it without a footprint. It would have saved months of planning.
Yeah. And I think that would have been a big help. It would have probably changed a lot of things for times when I was downrange in a lot of places that we were helping to support some of these troops that were in contact or in a location that was pretty austere out there. If they had this opportunity to have something like this 5, 10 years ago, I think it would save a lot of people's lives. But going into breaking down what this technical part of the challenge is, we're going to go into what DARPA pretty much has stated what it is. So the announcement basically says that the objective of the DARPA Lift Challenge is to significantly advance the capabilities of vertical lift unmanned aircraft system, or UAS, by achieving substantial improvements in payload to weight ratio. Currently, multi-rotor UAS provide simplicity, affordability, and ease of operation. However, their primary limitation is their low payload to weight ratio, which is typically falls at a 1-to-1 ratio or less. This restriction significantly limits their ability to carry heavy payloads or operate for extended durations. DARPA will address their shortcoming by incentivizing novel UAS designs capable of achieving a 4-to-1 payload to weight ratio. The DARPA Lift Challenge will award multiple prizes based on objective measures centered around overall payload weight, as well as subjective categories to recognize revolutionary designs. Now, let's break down the requirements, technical portion of the challenge to go over the constraints. The basic requirements for this is going to be the drone needs to weigh 54 pounds or less, and basically meeting the Part 107 requirements. Payload needs to be at least 110 in weight, and it has to carry that 110 for 4 nautical miles, but they will have to travel a total of 5 nautical miles. So the way it'll work is they'll do 5 laps. With on the 4th lap, they'll drop the payload, land, drop it off, take back off, and then finish out the 5th lap with no payload on it. And this needs to be done at 350 feet and within 30 minutes. That's going to be pretty significant to do all that with that much of a change in between. And a lot of current mid-size and heavy lift enterprise type drones struggle to carry even half that weight. There's only one maybe that's out there, and I want to say that even the DJI drone may not be able to really carry that much, but I have to look into that one to see. That's interesting to know. But to do this, you have to rethink power plant, routes, rotor span, or the lengths of the arms on a drone, blade pitch, maybe having to go back to using a squash blade if needed for a traditional type drone, frame materials, thermal management, battery discharge capability, center of gravity control, especially that's going to be a significant, more important than probably most of the things in it. That center of gravity, carrying 110 pounds and having that weight being shifted in on a sUAS, it's going to be a significant thing that they're going to have to try to figure out. But like I said, center of gravity, aerodynamic drag, flight control logic, which is going to be the biggest one too, because you're going to go from having to carry 110 pounds going up and coming back to flying without it also, and then keeping it moving. And we can't just slap motors, bigger motors on a aircraft and expect it to be able to fly. Because you're going to have a lot of power draw, which costs you more battery and or endurance over time.
Let me throw another real-world application from a SIGINT ops lens. When we used to forward deploy collection kits to remote positions, those loads weighed anywhere from 80 to 140 pounds. That's encryption modules, power systems, signal processors, patching harnesses, mounting gear, frequency converters. Moving that without a vehicle meant manpower risk, time exposed, and invisible movement signatures. A heavy lift drone could drop equipment at a standoff distance, a less chance of a compromise, less risk to personnel, and at a higher tempo. And that applies to communications nodes, radar transceivers, tactical relay boosters, and even RF denial devices. if you're trying to create a bubble, this is the great way to move your equipment.
Yeah. And when you think about all those, you got to think into the power and the systems that go into it, such as propulsion. 50-pound drone lifting 150 pounds or 110 in this case is probably requiring a lot of either changes between the hybrid gas electric system or a hydrogen fuel cell system, or even changes in battery types, like going from lithium polymer or lipo battery to, say, maybe a graphene type battery, lithium graphene type. Um, Even electrical alone might struggle with endurance, but having these augmented hybrid systems will help it to basically make it to where it needs to go to, and also help with endurance. But you also have a weight cost that you're going to get a penalty off of, because those hybrid systems also are going to add more weight to your aircraft. So you're going to have to try to eliminate weight in other places. And then you got the power draw from those systems. So having that massive draw from one and then changing over to the other, or having it where they're working in sync, you got to balance that all out, which not going to be a big problem. But this comes into play when you have to worry about now weather considerations or atmospheric conditions, such as going from a lower density altitude to a higher density altitude. So when you go to somewhere, say like Denver or White Sands, where you're already at a higher ASL or MSL, you're going to run into, now the air is already at thinner from your takeoff point, and then you're going into even thinner air going into your next altitude. So that's going to significantly wear on your batteries. It's going to wear on your ability to pick up heavier weights, and your draw is coming from getting just to altitude. So you're going to have to pick up and do a lot of this in more of a traditional way. So traditional helicopters will work out a little bit better, but they're going to have to work into figuring a better way to make these work well.
Well, here's where the DoD angle gets loud. I mean, in an A2AD environment, say near Russia, IADS or PLA, coastal umbrella, you're not flying Chinooks and Ospreys. The radar cross section, the IR signature, the acoustic signature, and the threat risk is just too high. A small, heavy lift UAS can fly low, navigate tree lines, avoid radar arcs, remain acoustically masked until close, and deliver ammo kits, intel kits, emergency medical gear, crypto, anti EW hardware. The small footprint resupply is the logical evolution of modern warfare.
Agreed. And structural change is going to be another change that's going to have to come with it, because of those problems that we see. We're going to have to go into having lighter frames, lighter type material, more efficient spread of the load across different centers of balance, and figuring out ways to spread that load across. Having to basically figure out airframes that are outside of your standard norm, and working into maybe a unconventional thought of it, motors having to be more conventionalized to this type of a need, props being set up in a way where they can actually work in a more aerodynamically efficient, avionics being able to be at a place to where they can be able to give information back and or recognize and understand what's going on while they're in flight. Power systems, specifically the power systems, because that's the primary need. That's going to be a massive change needed to come to the industry, where you're not just having these heavy lipo type batteries being put onto a system, because you can only stack so many of them, because now you're adding weight, and that weight reduces the amount of payload that you can carry. So that means changes in battery power being reduced to a lighter weight system for something, regardless if it's the battery or if it's a fuel. And also flight controllers has to, and having enough on hand to be able to fix and repair, and also a simplified GUI to go with that flight controller, so that just the everyday operator, such as a soldier on the ground, can use it without much of a problem, versus having something that's significantly more detailed that won't be able to just be readily fixed. And GPS and INS nav needs to be upgraded and being at a place to where it can be mitigated, such as what Josh was talking about earlier. and telemetry and system control, or a C2 in most cases. The C2 is going to have to be upgraded and be more tactical, and in a way where even if it's the AI or some type of autonomous system where it can still mitigate through EW denied areas and find its way, even without GPS, and be able to navigate, such as as dead reckoning, or navigate through watching or looking at things on the ground and finding terrain data. And if you can burn 10 pounds off and reduce that structural efficiency to be just what's needed and make it work well, not only will this change what we have in regards to the aerospace industry in the UAS world, but it could change aerospace totally in general, all through the realm of everything that we have in aerospace or in the aviation industry.
Yeah, in the field, the ability to move water, ammo, med supplies, radio kits, batteries is mission survival. When I advised on distributed collection ops, batteries alone were the nightmare.
You also need dynamic flight controls. So IMUs that are redundant and or efficient, such as something outside of just a regular Pixhawk, where one flight you're good, then you get 2, 3, 4 flights in, and then next you know you have something that you have to work out, which that isn't going to be comparable for a combat situation. You ain't gonna have time to sit back and say, oh wow, I got to restart my aircraft because the flight controller is not working right now, or go through doing a accelerometer cal. I wouldn't want to see someone saying I'm under fire and I got to do a accelerometer cal on my aircraft before I get it put up to go somewhere. So something that's more redundant and capable of flying without problems. Torque balancing, telemetry, health checks, load oscillation dampening, especially, is going to be a major need. And loads, I don't see them being able to put a payload on there that is actually sling loaded, because the center of balance and the way that these flight controllers work, kind of going back to the first one, it's going to have to recognize and be able to compromise for that. But it having that big of a swing is going to be a problem, and it could throw off a lot of them, which goes into oscillation dampening. When 110-pound swings in flight, it unbalances the aircraft itself and will cause the flight controllers to make a lot of corrections that you don't want to have. And this can cause drift, and cause a crash, and cause a catastrophic loss of the aircraft, and possibly break props in flight. And that will lead to a lot more problems if those things happen.
Another example for the defense context is a special ops unit are always looking for low signature mobility that avoids road movement and airframe risk. I've watched units spend 8 hours hiking spare kits to remote positions because the route was compromised, the roads were IED suspect, or vehicle movement was too observable. A heavy lift drone removes that risk. Silent ingress, standoff drop zones, and no compromise of force location. This is a doctrinal change, and it is huge.
Yeah. And we're not the only ones that's really doing or thinking about this type of situation. You look at places like Ukraine, Israel, China, and other countries, they're already implementing a lot of this, and some of it in combat type situations. And this is something that's, in our case, been needed for a very long time. We've had it and it's been there, but it wasn't an emphasis on it. So heavy lift drone, cargo drone being put in place is very useful. And you've seen some changes and some prototyping, but none of this, none in the multi-rotor aspect, normally been in the fixed wing type systems. And now you have military grade logistics stuff that you can actually implement into this and help them to move way quicker and faster. Long range payload carriers would be very helpful in the space of adding gear and parts. They can carry, say, an airplane part that's at a place to a downed aircraft, or in this case, a downed helicopter that needs to get a part to it that a helicopter that normally would go through could get shot down. You can get that part there without having to contest, because it's already in a contested space that can help them to get from where they are out and back. I know this is all like theoretical, but these are all validated battlefield situations that we know need to be fixed and brought into a place where we can save lives and not have to worry about causing more life at a problem, which means the U.S. defense ecosystem can't just lag. With this weekend, they just had the Reagan Defense Forum, and they talked about these things. So the lag is not going to be something that we have the luxury of going forward.
And that's why this 2026 challenge matters. In contested theaters like the Baltic states, Pacific Islands, or Arctic conditions, traditional resupply, landing strips, and convoy lanes are either vulnerable or non existent. Heavy lift UAS can sustain forward operations. Special teams, intel detachments, space domain intercept units, cyber and SIGINT penetration cells, shore based distributed marines. We've lived this problem. This challenge is trying to solve it.
Yeah, and for those who are thinking about doing this and taking into consideration, here's a possible engineering checklist that I could say would possibly be helpful for you. Think of carbon fiber or other lightweight frame material you can choose from that would allow you to be able to make your frame lighter. And also, you can start with there's other options out there. Aircraft that handles much like a traditional helicopter. If you can do something that's in that aspect of it, you would probably be ahead of the game in a lot of ways. Incorporating hybrid power situations, finding ways to be making these aircraft more resilient and capable of having a hybrid power that isn't just relying on one source. Because if we have multiple, that means that aircraft could probably fly longer. Motor layouts, thinking outside the box. Instead of your traditional octo hexcopter or even the H-copter type frame or the octo quad frame, thinking of it in different ways so that it can be very modular and also compact, but at the same time still have all the benefits of what a normal hexacopter, octocopter, or whatever, even a quadcopter type situation. Figuring out high torque. What you're going to need to get that aircraft off the ground is your thrust, and figuring out that torque requirement is going to be key. Centralizing the shock of the payload or centralizing your payload in general, figuring out what your CG. If you can figure out a way to make that CG modular and maybe not just consistent to just one spot, and be able to move and not cause that aircraft to have problems with getting its airspeed or throwing it off and causing other problems like dampening isolation issues, you could pretty much get through or even come up with a novel idea that could not be known by others. Efficient lightweight systems, just coming up with ways to making the aircraft that literally is just the aircraft and then not all the extra bells and whistles unless they're needed. IMUs, building out your IMU to be if you have it already and you have something, you may actually have something that could be useful to a lot of these companies already. So maybe marketing that out and say, hey, our IMU is more resilient and is shown to be able to do it under all these stresses. RF hardening and telemetry to resist EW. So if you can come up with a system that is able to still function even in an EW hardened area or can work through it, you're ahead of the game in a lot of ways. And rapid folding frames if possible. If you can make it to where that aircraft, once it's on the ground and is let go of its payload and now can be broken down to be put into the back of a Humvee in a 5-ton, any other military vehicle, you can be able to now make that as a system that could save someone else's life. So it gets from one place to another, and then you won't have to worry about much of other problems. And you're also making yourself a financial opportunity there that may not have been there in the first place. There's another interesting angle to this also. This challenge is a pathway for veteran-owned companies or disabled veteran-owned companies, small defense startups, university joint ventures, big primes that may want to attempt this, but they are moving a lot slower. So as a small company, you have an ability to work faster, take more design risks, pivot in a mid-engineering process versus whereas you're reporting in a big company, they want to see the process and the progress and then expect you to kind of keep to the test plan. Whereas in a small aspect, it's on you. And the same thing comes with the risk. With risk comes reward and non-reward, whichever you want to see it as. But understand the smaller company has ability to move way faster and way quicker. So we have opportunities. Think about it and try to take your knowledge and your abilities and put in an environment that will solve that challenge.
Yeah, and from a mission perspective, modularity matters. Military users don't want single purpose platforms. If I can drop med kits on one sortie, SIGINT equipment on another, batteries on the third, or even a comms repeater mesh node with the same drone, it's invaluable. Mission flexibility is key.
Yeah, and the technical part of this is achievable. But if we don't think of it in a hobbyist, or if we don't start to think of this in a hobbyist quad build like situation, um, we still kind of are hemming ourselves up. So don't put yourself in a position where you're only putting it at a high level, but think of the small person and the simplicity of it that you have at that level. Think of like an aerospace engineer. If you are on a hobbyist level, what would they possibly think about? And you have all the tools. We have different AIs that you can use. You have all the internet. You have libraries. You go back to a traditional way of looking at books and reading and find out that information. This is not just rotor science or aerodynamics loading. This is structural optimization and modeling. But for companies that take on the challenge and take this serious, it is a difficult but feasible task. So don't just hinder yourself thinking it is not possible. In my experience, I built aircraft that weighed 14 pounds that could carry at least 12 pounds to 20 pounds up to 2,500 feet and back, with the situation of having a risk of I needed to get to altitude, and if it didn't, if the payload wasn't able to be dropped, I could still bring that aircraft back. I've had aircraft that could need to do that, but if I didn't let go of my payload, I wasn't going to make that aircraft back on the ground. So I was successful in accomplishing my missions and doing these testing, but it came with risk in the whole aspect of it. So these are feasible things. You just need to know what your limitations are. Will it be difficult? Yes. Is it impossible? No.
So, to the veterans listening, if you were an aircraft maintainer, if you worked power systems, if you were ISR, or if you were in procurement, or you ran tactical logistics, or you've seen the cost of resupply in denied zones, this is your domain. This challenge is exactly the kind of effort that needs veteran experience. We know the real mission constraints: crew safety, EW threats, recovery, silent ingress, load stability, denied terrain. We've lived it.
Yeah. And U.S. government challenge isn't just a design competition. It's a call for innovation. It's the next evolution of tactical mobility. It's the first step towards unmanned air logistics and becoming a standard for distributed operations, rapid resupply, force sustainment, Arctic and island deployments, and high risk contested operations. If this technology matters, the battlefield logistics changes forever.
And I'll say this bluntly: the first company that solves this redefines how the U.S. military moves assets, sustains missions, and preserves lives. I think it's achievable, and I think veterans with DoD context, problem solving, under pressure, and real mission experience are uniquely suited to build it. If you're working on this challenge, reach out to us. We'd love to collaborate, brainstorm, and share some ideas. Thanks for tuning in, and we'll see you in the next episode.
And again, it's good seeing you everyone here again, and have a good one. Thank you.